Uh, Good morning, everyone. So today we are going to discuss about our the previous the today we are going to discuss about the network model. In the previous session, we were discussed what are all the network methods and what are all the things has been utilized in this network model. So now we are going to have a problem with the network model. So the first problem here. So the first problem, here the example given, an assembly, the question is an assembly is to be made from two parts, X and Y. Both parts must be turned on a lathe, Y must be polished whereas X need not be polished. The sequence of activities together with their predecessors is given below. So here the table has given activity, that activities are A, B, C, D, E, F, G, H, and then the descriptions for the following activities. For A, it is open work order and open work order. The B get material for X, and C get material for Y, and D turn X on lathe, and E turn Y on lathe, and F it is polish Y, and G assemble X and Y, and H pack. So for the predecessor activity here given, for A it is a nil event, and for the B it is the predecessor activity is A, and C it is A, and D it is B, and E B and C, F it is E, and G D and E, and H it is G. So through this table we are going to draw a network diagram of activities for this particular project. So here, so you can just see the table. Through the table we are first to draw the table. So here it is the activity A, B, C, D, E, F, G, H. For the activity A, it's a nil event, so the predecessor activity is nil, so we have to put it as a dash. So for the B, already it was there through the table, through the given problem. So here the A, B, B, C, E, D, F and G are all the predecessor activity. So through this network diagram for this project, so first we have to start up with the node 1. Through the node 1, we have to draw a network from A. So the network, the activity A has been taken here. So through the A, so there is no predecessor activity, we start with A. So that is what, so the the network, the activity event node 1 through the activity A from node 2. And then the next activity is B, the predecessor activity is A, and the next activity is C, and the predecessor activity A. So from the predecessor activity A, we have to draw a network, activity B and C. So that is what we have draw the activity B and the draw a activity C, and that will be displayed 3 and 4. So from the activity A through and from the activity A, so we have to draw a activity B and activity C, and the next activity, so we have completed A, B, C, and now the next activity it is D. So from the D, it is the predecessor activity which is B. We could not write the number here because the next activity E has been there. Through the E, the predecessor activity which is B and C. So if it is B and C, there is a activities which is from B and C. There is a activity from B to D, and there is a activity B and C. There is a E. So if it is B, so we have to draw from the node 3 to 4. 3 to 4, we have to draw a dummy activity. So that is what here the dummy activity, it mentioned as dotted activity here. So the dummy activity is here. So for B and C. So through the E activity. So if you are completing this, the node will be identified as 5. So after that, the B to D, the activity B to D, it mentioned as C, because here it is F, E is B and C, and the next activity F has been taken here. Through the F, so we have a predecessor activity here, it is E. So therefore the predecessor activity E, through we can draw a network activity which is equal to F. So that will be mentioned as sixth node. So from the sixth node, so we have completed through the table A, B, C, D, E, F, A, B, C, fourth, fifth and sixth activity has been completed. but the seventh activity it's named G, but it is the predecessor activity which is D and F. So here it is D and F. So the D and F followed by the followed the activity G. So we have to mention as G the node value which is equal to 7. So from the last activity which is H, so through the H the predecessor activity which is G. So therefore, so from the G, so we have to draw a activity H, then the node will be identified as 8. So this is what the network diagram for the given table. So through the table, so we have they have given in the descriptions for the problem. Through the description we have to take up the predecessor activity, and through the predecessor activity we have to draw a network model. So this is called a network model. And the second example, the same way we are going to work out here. And the second example, I'm not giving in any descriptions here. So I'm just started with the table. So through the table we have an activity, and we have a descriptions, and we have a predecessor activities here. So the question is, draw a network diagram of activities of this project. So you can just see here the activity A from J, and the predecessor activity for starting A, which is nil event. So therefore the nil node, so we have to start up with the A activity. So here I am just starting with the solution. So through the activity which is start from A to J, and the activity A, the predecessor activity is the nil event. So therefore we started from the node 1 to 2, and the activity is mentioned A. Okay, and then the next activity which is B, but the predecessor activity which is A. So if it is the predecessor activity which is A, and the next predecessor activity which is B, it is not the A. So after that P, we have some other activity is there. So we have to draw a first activity A, and then node has been identified 1 and 2, and then the second, from the second node to third node, the activity which is B. So therefore the first two activity has completed, and the third activity C, which is predecessor activity. C has a predecessor activity which is B. So therefore we have to draw a network from C. So that C will be identified, the node will be identified as 4, and then the next activity which is D, next activity which is D from the B. So you can just see the predecessor activity. There is a 3 predecessor activity B, B, B. So from the B we have to draw a network for C, D, E. So the first diagram, so I have written C, the activity C, and then activity D, and then activity E. So through the activity E, and we have the next predecessor activity which is C. So the predecessor activity which is C, through the C, it is the activity says F. So we have to draw a network for the node which is 5. So this is F activity, and then again the same C, we have to draw a network for G. So the G activity is happen. So through this G, we have a node identified as 6, and then and through the H, I mean the activity H, it's based on the predecessor activity F and G. So F and G, so we have to get the activity which is H. But from the node 4 to 6 we have a activity G. But from the node 4 to 5 and 5 to 6 we don't have any activity here. So that is what we have to draw a dummy activities here. So 5 to 6, that is that it is called D2 here. So from the D2, so we have to draw a network which is H. So that H is identified as the node 8. And then the next activity which is based on the predecessor activity D and E and H. And 3 activities are merged with I. So that I which is started from the node 8 and node 8 to 9. So the I will be the activity, and through the I activity represented through the node 9. So from the node 9, so we have to draw a activity J. So that will be ended with, and that will be the predecessor activity which is I, and ended with 10. So the node which is 10. So this is what the next diagram, the network diagram. So through the network diagram we have to follow the critical path method and the critical path analysis. And here there is a third example. So here I am just giving descriptions. So listed in the table or in the activities and sequencing necessary for the completion of a recruitment procedure for management trainees in a firm. So it is like a human process, I mean a human resources techniques, human resources allocation has been taken here. Through the human resources allocations, we have to draw a network diagram, and through the draw a network diagram, so we have to analyze the allocation of the resources. So through this problem, so there is an activity from A to O, and there is a descriptions and the predecessor activity is here. And if the problem has not given the parameters of the descriptions, so we have to make it in the making into our project oriented descriptions. So here there is A asking units for requirements, ascertaining management trainees requirements for the commercial functions, and so on, and up to final interview. So this is what the descriptions of this given problem. So we are going to draw a network diagram for this this project. So here it's a very lengthy problem. So here the activities start from A to O. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. So there is 13 activities are here. 13 activities are here. So we are going to use the we are going to draw a network model here. So through the activity A, there is a nil event. The predecessor activity is nil. So we are going to make it from the node 1 to 2. So the activity is A. So this is what here we have mentioned, 1 and 2, there is a activity A. And then the next one is the activity is B. Activity is B, but the activity is B, the predecessor activity is A. And again the predecessor activity is A for C. So there is an activity from A to B and C. So that is what B and C will be draw it here, and the activity B is there and activity C is there, and node will be identified as 3 and 4. Node will be identified as 3 and 4. Now the next is D. The activity D is depends on C. The predecessor activity is C. So from the C, so we have to draw a network, the activity which is D. So therefore the next activity which is E, so the E is based on the predecessor activity which is B. So therefore, so we have to draw from the node 3 to 5 and 4 to 5. So these E and D should meet the node which is 5. So therefore the next activity which is G, the G is the predecessor activity which is equal to the G predecessor activity which is D and E. D and E. So there is a D and E. So we have to draw a activity which is G, and the result of node which is mentioned as 7. And the previous the activity F. The activity F is the predecessor activities which is C, and which is identified because it is sixth identity node. So we have to mention as the node as 6 here. It is F, and the activity F and the node which is 6, and here it is G and it is 7. Then the next is H, the activity H, the predecessor activity which is G. So already we have the node 7. So through the node 7, so we have to write the activity which is H, and that should be not mentioned as number. Now we are going to take up the next activity which is I. So that I and J, so I, H is the predecessor activity which is G, and I which is predecessor activity which is I. So and the J which is the predecessor activity which is F. So here from the F activity we have to draw one more activity which is J, and we have to identify this number. Maybe if it is here it is 8, or here it is 8, or here through the diagram here we are mentioning here it is 9 and here it is 8. So you can just make it as 8 and this is 9. So here we have to write this activity which is the node which is 10. And then the next activity which is K, and the K is the predecessor activity which is I and J. So through the K we don't have any value, because in the next activity which is you can just see here the next activity which is J, again there is a J. So through the J we have a through the j we have an activity, the predecessor activity is j, the activity which is n, the predecessor activity is j. So through the j we are going to write the activity n. So here it is n and here it is k. So therefore, so we have to draw a dummy activity from this j. So the dummy activity should be reached through the node 10. Then we have to draw a 10th node, and then we have to draw a activity k. And then the next activity which is L, and the predecessor activity which is k. So we have to write the activity from 11 to 12 and the activity which is L. And M, the activity M, the predecessor activity which is L, automatically it goes to the next line. So automatically the next row will be there, and automatically 12 to 13 the node will be 13. And then now it is N. So from N to, from already we have J to N. So J to N, there is a activity 8 here, I mean the node 8 is here, and the activity N will be reached to 13. So that is what it is to be, it is the predecessor activity which is j. So we have to draw like this, or we have to draw like this. So the 13th node will be there. So from the last activity which is O, and the predecessor activity from the M and N, so already we have M and N, and finally we can conclude the activity which is O. So that is the node which is identified as 14th node. So this is what the diagram, network diagram. So we can just create the network diagram as per this activities and the predecessor activity. Here there is one more examples here. So through the activity A, B, C, D, E, F, G, H, I, J, K, and from the activity the predecessor which is equal to, for the activity A it is a nil, and B it is a nil, and C it is a nil, and D it is A, and E and F it is B. So from the B there is a different activities have E and F. So and G it is based on the predecessor activity which is C, and H which is the predecessor activity which is D, and I the activity predecessor activity which is E, and J the predecessor activity which is H and I, and K the predecessor activity which is F and G. So this is what we are going to construct here. So start from the event, the node which is start from 0. Here it is 0. So or 1. So we have to mention as 1. So the node will be started with 1, and there is a 3 nodes will be there, 3 activities will be there, A will be there, B will be there, C will be there. And then based on the D, the activity D, it should be comes from, it's the predecessor activity which is from D. So we have to draw it here. So D activity, and the node will be identified as 5. And the next activity which is E. So the E is based on the predecessor activity which is B. So we have to draw from the node 3 through the activity from the node. So we are not going to mention the number. Now the next thing is F. So the F is also from B. So we have to draw a F, and we could not draw a node here. We can just stop it here, or just we can just put it around it here, and then we have to check it the G. I mean the G is based on the predecessor activity which is C. So from the C, so we have to draw a network, and you can just see here the H, and H is based on predecessor activity is D, and I is based on the predecessor activity E, and J is the predecessor activity on H and I. So automatically here it is J. And the one more activity K, the K will be start from the activity F and G. So here the F value will be, so here it is S, and here it is F. So there is a F value which is like a dummy activity for this line. So we have a dummy activity for this line, but we don't have dummy activity. Directly we have for the, so we don't have through the activity, the predecessor activity. So here it is F, the predecessor activity is B. So we have to draw a line, I mean through the node it is 7. So through the 7, so we have to draw a final end of the node which is 9. That is the activity K is there, and the activities J is there. So this is what the conclusion of this particular problem. So through the network diagram, so we are going to find out the critical path analysis is also there. So through the critical path analysis, so here the it is the longest path through the project network. The activities on the path are the critical activities. Therefore, any delay in their completion must be avoided to prevent delay in the project completion. This is what we are analyzing through the critical path analysis. The objective of this critical path analysis is to estimate the total project duration. And in the previous problem, one of the problem we have given the duration. So we are going to analyze the durations, and we are going to simplest way to the network model we have to create it, and then we have to analyze the duration. If it is the duration is very lengthy, so we have to minimize the network model, and we have to minimize the duration. So this is what the conclusion of the critical path analysis. So here the objective of the critical path analysis is to estimate the total project duration and to assign starting and finishing times of all activities involved in the project. So this helps to check the actual progress against the scheduled duration of the project. The duration of individual activities may be uniquely determined in case of CPM, that is critical path method, or many involve the 3 times estimates in case of PERT, that is program evaluation review techniques, out of which the expected duration of an activity is computed. So having done this, the following factors should be known in order to prepare the project scheduling: and total completion time of the project, and earlier and latest start time of each activity. So this is very important for our critical path analysis. And the critical activities and the critical path is there. Float for each activity. Float for each activity means it's the duration. Based on the duration, and the floating point will be identified through our upcoming problems. So that is the amount of time by which the completion of a non-critical activity can be delaying without delaying the total project completion time. So here the critical path method, we have some points are there, and the events, through the events and the activities. So notations for the purpose of calculating here, we have to denote some notations. So here the following notations are here. EI. The EI is the earliest occurrences time of an event. I. This is the earliest time for an event to occur immediately after all the preceding activities have been completed without delaying the entire project. And LI, that is latest it's a latest allowable time of an event. I, this is the latest time at which an event can occur without causing a delay in already determined project completion time. And ES, yearly starting time of an activity related with IJ. So this is the earliest time an activity can possibly start without affecting the project completion. And the latest starting time of an activity, that is LSJ. And yearly finishing time of an activity, that is EF. And latest finishing time, which is denoted as LFIJ. And the duration of an activity, which is mentioned as TIJ. So it has already been mentioned in a network diagram. There should be one initial event and one end event. So the other events are numbered consecutively with integer 1 and 2 n. So in the previous network model, already we have put it all 1, 2, 3, 4, 5, all the nodes. So one problem we have mentioned as start with 1, 0. So maybe 0, 1, 2, 3, or 1, 2, 3 up to etc. n. So such that I is less than j for any two events I and j connected by an activity which starts at I and finishes at j. So for calculating earliest occurrences and the latest allowable times of events, the following two methods are there. The one is for forward pass method, and the second is backward pass method. So here it is the forward pass method. We use forward and backward pass method in CPM PERT to find the earliest and latest occurrences times of events. And the forward pass calculations are used to find earliest occurrences times of events, that is EI. Forward pass calculations are from left to right. Start value is equal to 0. Earliest occurrences time of first event, which is start from 0. And when two or more activities merge in an event, the maximum value is taken. Suppose for example, from the 1, 2, 3, there are two activities, there are 3 nodes. From the 2 activities, So from the two activities, we have to take up the earliest earliest value. So we have to take up the maximum value. We have to take up the maximum value. So through the problem, we are going to discuss all these things. And the forward pass time, which is equal to earliest time of tail event plus activity time. So this is the formula for forward pass time. And the backward pass method, which is calculations are from right to left. Backward pass calculations are used to find the latest occurrences times of events, that is Li. For the latest last event, that is latest time, which is equal to earliest time. If there is more than one activity coming back in an event in backward pass, we have to take up, suppose from the last end. So the final node will be there. From the final node, we have to take up the two activities are there, backward pass method. If we are going to take up any value, so we have to take up the minimum value of that activities, minimum value of that activities. So therefore, the backward pass, we take a minimum value. So the latest time of head event minus activity time. So that is the backward pass method. And here the same process will be repeated. So the certain activities in a network diagram of a project are called the critical activities, because delay in their execution will cause further delay in the project completion time. Thus all the activities having zero total float where value are identified as critical activities. The critical path is the sequence of critical activities that form a continuous path between the start of a project and its completion. This is critical in the sense that if any activity in this sequences is delayed, the completion of the entire project will be delayed. The critical path is shown by a thick line or double lines in the network diagram. The critical path is shown by a thick line or a double lines in the network diagram. The length of the critical path is the individual times of all the critical activities lying on it and defines the longest time to complete the project. The critical path on a network diagram can be identified, that is EI, which is equal to LJ, EI, which is equal to LI. On critical path, EJ minus EI, which is equal to LJ minus LI, which is equal to TIJ. That is the time duration activity.